In the last video, we created this JUnit to test the greet message of the greeter. We give it an input and we get the output, then we test the output with the expectation using the assertions. Now, JUnit has many annotations. It is heavily annotation driven, and we can check the documentation, the official documentation of the JUnit5 in the user guide. We see a huge list of supported annotations, and we will be covering most of them, especially the important ones required to write the JUnit test cases. We have already used one @test to mark a method that this is a test method so that JUnit framework can run that test case. Now, before we start anything else, let's give it a meaningful name. Right now, if we run it, we see the name of the test case, test greeter, which is basically the name of the test method. By default, it uses the name of the method as a display name. But there is another annotation in the JUnit that can be used to provide a meaningful description to the test case. So let's say we give it a meaningful name. We say that testing greet message input output, or let's say output and expectation should match. So here we gave a description to the existing test case. Now if we run the test case, instead of the method name, we see the description. So we see that there was a test case with name testing greet message output and expectation should match, and it is green. So when there are many test cases and we are running maybe the whole suite, then the description matters because it is easier on the console to see which message or which method failed, and whatever the test case is, what exactly is it testing. So the intent is clear. We can use the display name just for the clarity. All right. It's important that we understand the life cycle of a test case. To write a test case, what we do first, we create a test class. Then in that test class, we add methods annotated with @test annotations. We can call this class maybe a test unit, and all the methods are called test cases, JUnit test cases. We know that if this is a class, then someone will create a new object of this class before running the test cases, and this someone in this case is the JUnit framework. So JUnit framework will create a new object of this class, and with the help of that new object, then it will run the JUnit test cases. We can verify that. Right now this class has a default constructor, no argument constructor, that will be called by the framework, but we can override that. We can add a constructor because technically this is a class, so we can do that. And we can add a message initializing test class. And if we run the test case now, we see the message from the constructor. That means the framework called the constructor, it created a new object, then it executed the test case. What if we had, because a test unit can have more than one test annotated methods, a test unit can have many test cases. So let's add another one, a dummy test case. With a dummy assertion. And let's run the test class again. to execute all the test cases. In this case, there are two. So we see both the test cases are success, but on the console, we see the constructor was called twice. It means the framework created two new objects of the same class in order to run two different test case method. Okay. If we add another test case, dummy1, and this time if we run the test case, we see three messages on the console. That means the constructor was called 3 times. So the thing is, what JUnit framework does, for each test case in the class, it creates a new object every time. So that is an important thing to understand on the life cycle of the test case. For each test case in the class, JUnit will create a new object of that class. Why does it do that? It does that to make sure that each test has a clean slate. Because maybe there is a shared state, maybe we created some instance variables, maybe we are maintaining some temporary data, and one test can make some changes in that test data that could impact another test. And we are trying to test the unit in isolation. So this is the perfect isolation that framework is trying to achieve. And since each test case is executed by a new object, that means the test cases there is no dependency between the test cases. They are not dependent in any way. That also means that because there is no dependency and they all are running with a new instance, that means there is no ordering guarantee. They can run in any order and that will not impact the run of test case in any way. So that is a good thing actually. That's why it does that. Now, there is a property in the JUnit framework provided by the framework. With that property, we can control this behavior if we have a use case. By default, the behavior to create a new object of this class is per method. Here, the method means the JUnit method, the method that we annotated with @test annotation. That is the default behavior. To create the new object per method, that means for each test method, a new object will be created. We can override this behavior with the TestInstance annotation. We see that there are two properties, per class and per method, and we discussed that per method is the default behavior. We can change it to per class. If we do this now, it means that we are saying create a new object per class and use that single object to run all the test cases. If we run the test case now, or the entire class now, we see 3 test cases were executed, but there is a single message on the console. So we know that only a single object was created and that object was used to run all the test cases. So we discussed two things, per instance and per class. All right. Continuing our discussion on the lifecycle methods, next we are going to focus on 2 lifecycle hooks provided by the framework. So let's write them first and then we will discuss. The first one is BeforeEach. So we write a method, let's say setup, and annotate this method with BeforeEach. For now, we'll simply print a message. And the second one is after each. We do the same thing, we write a method. And a message. What they do, they give us an opportunity to do something before running a test case, then doing something after that test case completes. So before and after activity of a test case. And they will be triggered for each test case in this test class, before and after. Now sometimes we may need to set up some temporary data for a test case. We may need that in the test case. That we can do in the before each, if that is to be required before each test case in the test class. Similarly, if we have to tear down something before the next JUnit runs, so we can do that in the after each. Now we have a constructor, we have a before each and after each. Then we have two test methods and we'll see the order. Although constructor is there only for the clarity, it doesn't require, we don't need this constructor for the actual test class. If we run the test class with two test cases, we see first of all the constructor was called, framework created a new object. Then before running the test case, it called before each. Then this method, test method, was called because I added the print message in the test method. So we see in test greeter, then we see after each was called. So this basically creates a single unit before test case and then after, before and after lifecycle hooks. Then because we know the default behavior is to create a new object per method, so we see the constructor was called again, a new object was created. Again we see the before each, in dummy and after each. In dummy is basically the print message in the dummy test case. So that's how we can do some things, pre and post things using before each and after each annotated methods for each test case. And we will use this in many ways in the upcoming lessons. All right. There is one more thing remaining on the life cycle of a test case. In the last video, we saw the use of before each and after each, pre and post activity. JUnit provides another lifecycle hook similar to this, BeforeAll and AfterAll. The difference is BeforeAll and AfterAll is common for all the test cases in the test class. They will be called once before all the test cases and after all the test cases. While before each and after each, they get executed for each test case, before all and after all, they will be executed only once. Okay. So let's try that. Before all is an annotation that we will use to annotate a method. Public void start. So we name it start. And a message before all. Similarly, after all, we name it end. Okay. So we have the constructor, then before all, after all, before each, after each, and then two test cases. Okay. Now let's run the test case, the whole test class. So we see an error. It says that before all method, this one must be static unless the test class is annotated with test instance per class. We have already seen the use of this test instance. It is used to control the behavior, whether to create a new class per method or per class. So because the default behavior is per method, that's why it's saying that method must be static. Because if you think about it, before all and after all, they are going to be executed only once. So they are same as the static in the Java. That's why the rule is to make them static. So we add the static and retry. This time we see that even before the constructor was called, we see the message before all. Now I hope you understand why the requirement was to add this static, because they need to be called before the constructor, before the object. That is the job of static, right? So we see before all, then we see the constructor, then we see before each, then we see the test method was called. After that, we see after each. So this completes the execution of one test case: constructor, pre-activity, test case, and post-activity. After that, for the second test method, the dummy one, we again see the constructor was called because it will create a new instance. And then we see before, pre-activity, test case, after activity. And when all the test cases are complete, in the end, we see after all. Purpose is same as before each and after each. The only thing is, if we have something to set up and clear, and that is common for all the test cases, we want that to be happen only once. In that case, we will do that activity in before all and after all. If the requirement is to do that thing before and after each method, then we'll do the same thing in before each and after each. All right. And just for the winding up of this topic, let me remove the constructor because we don't really need that constructor. And we'll run the same class again. And that is going to be the setup for many test cases in real life also. So in many test cases, we may need before all and before each, after all and after each, all the lifecycle methods along with the test cases, or we may only have before each and after each. So it depends on the use case. But this is a valid setup, a valid test case setup for a real project also. All right.